So I'm really excited to be here today and talk about Retrieval Augmented Generation. AI is a really passionate topic for me. So let's get started. My name is Kristian Mariyanov. I'm Principal Software Engineer in Progress. I have around 10 years writing code. My last year was solely dedicated on working with AI, both inside Progress and outside for my personal projects. Enough about me. Today we'll talk about Retrieval Augmented Generation. We'll talk about how we can fix some of the problems of large language models. We'll then showcase a simple demo using RAG workflow, and we'll talk about different RAG elements in the typical workflow. We'll briefly mention some advanced techniques on how you can improve your retrieval using vector databases, and I hope we can have some time for Q&A. Before we start, I want to ask you a few questions. With raising hands, how many of you have used AI at least once? Okay. Everyone. And how many of you are using AI daily? Good. How many of you have used RAG to build a simple workflow or complex? A few people. Okay, so what problem solves RAG? The most common problems of large language models are first, maybe the most common, is the reliance of the static data. Base AI models cannot access the internet, and they don't have real-time information. They are trained on some data which is scraped from the internet. They also don't have access to some specific domain knowledge. Maybe this is knowledge which is private, or even maybe it's not part of the internet at all. Additionally, LLM have some problems with so-called hallucinations, and this is some kind of inaccurate responses. It could be, it actually most common for factual data, because hallucinations can be also seen as creativity of the model, and it may be useful for some things like idea generations or brainstorming, but for factual data like writing code or financial calculations, they are not really great. Additionally, we have some restriction on the context length of the models. Nowadays, we have models with really large context length, like the Google Gemini models, but most common models of OpenAI have around 128K tokens, which is not so many. And we have two approaches when we're trying to fix these problems. The first one is fine-tuning, and the fine-tuning is basically trying to retrain the uppermost tiers of the neural network using a lot of data. You have to prepare a new data set, and then you have to retrain it in order to improve the model for your use case. Fine-tuning would be a topic for today, and we'll talk more about RAG. And what is actually RAG? RAG is Retrieval Augmented Generation. The generation part here is actually the generation which comes from large language models. But retrieval and augmented is the new part. Retrieval is getting information from some external sources, and then we have augmentation, which is adding this information as a context to your prompt for generation. Here we have a simple chart that visualizes this workflow. And if you see the right column, we have a prompt with passed to the large language model. And we have response. This is the typical model. But when you have RAG, you actually have access to some external sources. And the retrieved documents are passed inside your prompt. Let's look at the simple example for this. Imagine that I want to ask a chatbot, should I bring an umbrella today? And if I use a base model, it won't be able to answer these questions. Why is that? Because it doesn't know my location and it doesn't know the weather forecast. It's not part of the training data. It may start to answer something, but it won't be correct for sure. But if we have some RAG workflow, we can get the location from my IP, for example, and we then can get the weather forecast for this location. We can then augment the prompt using this weather forecast and leave the large language model to reason and tell me yes or no. And now I want to share a simple demo using RAG. I have prepared here a simple application. This application works with a data set which is of the presentations of ISTA 2024. And I can ask different questions. When I ask a specific question, is it? Oh, it's not visible. Oh, I have to leave. Okay. Okay. I think it's now visible. Perfect. So I have simple app and which implements RAG workflow. It uses the JSON file that contains all of the lectures of ISTA. I can ask questions that have context of the ISTA conference. Let me see. Can you see the screen good? Maybe. Okay. Let's start the demo again, and let's try again the question. I expect to see not error, but actual contextual answers. And here, maybe I will just share what it actually should return. And we have answer from my RAG workflow, which is basically implementation using Python framework LangChain. And I compared this with the base model. The answer of the application is something that considers the context of the lectures, and it answers correctly that what is the lecture of the presentation for Selenium. I can ask additional questions like give me an overview for a certain presentation. And this workflow in the code looks like this. We have loading of the data. We also have some splitting into smaller chunks. And then we have preparing for the documents which are inserted inside a vector database. We are using here two OpenAI models. The first one is for embeddings, which is creating vectors from our data. We'll talk about this more later on in the presentations. And we are also using a model for reasoning, GPT-4o Mini. You can see that here in the prompt, we actually have a prompt which contains the question, which is here the query variable, and also some retrieved results, which actually data from retrieved from the vector database. And then we send this whole prompt to the large language model and get result. I'm not sure why it's not running right now, but let's get to the presentation again. Now we'll talk more about different RAG elements. These are the most common parts of the RAG workflow. First, we have loading documents. Documents are typically parts of the maybe web pages or JSON files. It could be part of your private database. Loading documents is actually just getting and parsing these documents inside memory. We also may need to clean the data, especially if you have data which is proprietary or contain some personal data. You may need to clean this data. Here we can clean personal names or brand names using named entity recognitions software. These are small transformers model which categorize each part of the text, and you can remove just the names from the text. But for example, if you have some complex code which can contain proprietary parts, you may need to manually clean your content. Additionally, when you have cleaned code, now we want to split this content, these documents, into smaller chunks. And I can visualize why this is needed with a short example. Let's imagine that we have Lord of the Rings book, and I want to have a question regarding one of its chapter. And what can I do if I have a whole document containing the book? I will pass the whole book to the model and ask the question. But most probably, this will result in an error from the large language model, and this because it will exceed the context length. Even if the model is with large context length, we won't have a good answer because we passed so many information and overload the model. It won't get really good performance. Additionally, the cost will be really high because we are paying for the tokens, and each time we have additional questions on this topic, we will have to pass again and again and again the whole book. So for this reason, we want to split the documents into smaller chunks and pass only relevant chunks when we're asking questions. Once we have these splitted chunks, we want to embed them, which is actually transforming the data into vectors. Vectors are like an array of numbers. The numbers are typically between -1 and 1. And we are doing this embedding using embedding models. These models can be used via API, or it can be also locally hosted. They are actually really small, so even if you are running the model on the CPU, it's okay to use it locally. And these vectors, each number of these vectors are actually dimension in the vector. These dimensions are then used to compare and find the actual relevant chunks later on in the vector database. When you have already embeddings, we want to insert them inside our vector database. We typically add some additional meta information to the documents. This can be used in order to filter these documents, additionally to the relevancy of the documents. With the example that I gave earlier, we had JSON with all of the lectures, but we also have additional metadata for the track of the conference. So at some point we would want to filter all of the lectures in a certain track and then filter by relevancy later on. And by the way, we have all of these steps until now that they are actually preparation for our workflow. They are done typically before we are running the actual query of the user. But the similarity search is the last step, and it is done when we are requesting answers and when we are running the workflow. The similarity search is typically performed in the vector databases, and it compares the different numbers in the vectors using simple mathematical calculations, and it can return the most similar chunks of information from this vector database. So we have RAG workflow, which is mostly dependent on its retrieval. The performance of RAG is depending on how good chunks will return from your vector database. So in order to improve this, we have some advanced techniques, mostly related to improving your retrieval, because this is the Achilles heel in this flow. And we won't be able to speak about all of them, but I want just to briefly mention the ranking approach, which is also visualized here in this graphic. And it actually contains additional model, which is called a ranker. This model is used to additional score each of the chunks and choose better what to pass to actual large language model. It contains getting more data from your vector database and passing instead, in this example, getting top 3 or top 5 results. You may need to get top 20 or top 50 results, passing all of these results to the model, and then adding only top scored chunks to your large language model prompt. We have some query expansions and other advanced techniques. They are mentioned also in the resources in the end of the lecture. So, as summary, retrieval augmented generation is a really useful approach when you're using real-time data and when you want to improve some of the problems for large language model. We showcased some of the examples, and you can use RAG in order to solve some of your problems. We now have some time for Q&A. There.
No? Tested? Oh. So you mentioned real-time data, but in the process you showed, you need to do some processing on the data source in advance. How does that work?
Yeah, typically RAG can be used as a term for some kind of retrieval. The approach with vector database is the most common one. It can also work with real-time data, but you need to update this data regularly. You can update this data every hour, every day, or every week. But in addition, you can also work with web, for example, in order to retrieve some data. For example, in the keynote, the speaker showcased Copilot, which is actually working with documents from email and other parts of the company database which is actually a different kind of RAG without vector database.
Other questions? Okay, so actually I have one question. You actually showed that RAG is a really powerful method or model. I'm not sure what exactly it is, how to call it, but what I would like to ask is what are the use cases that we would like to, what are your recommendations, when to use this, when to invest in this?
Typically, most common use cases contains a customer care chatbot, something that you cannot share like support tickets in the whole internet, so it can the base model would learn. Additionally, it could also be used for some personalized assistant, which actually get information for yourself, like notes or preferences or so on. So these are most common use cases. In the enterprise environment, it's used so that it can be used in a Copilot to access some data from your private database or cloud. So it's really diverse. But I think the most common use case is actually customer care for now.
Customer care for such data, and obviously optimizing the calls to the public APIs for the models that are used.
Most probably, if you want to do customer support using for a certain product, maybe the model won't be able to answer all of these questions. But when you provide additional context using your context for this customer, it will be able to answer relatively better.
Okay, got it. And we have a lot of stages and approaches in order to make this work. You mentioned that you're going to share after that the slides and the reference to all the tooling used.
These are the resources. I think they are all in the presentation. The example for this demo that didn't run well is actually in my GitHub, so you can try to run it by yourself.
Okay, thank you.
Thank you.
Okay.